haven't gotten any of the assignments, you still have assignments out from Chapter 7. I'm going to give you all till Monday to get them turned in since there's so many people gone for the weight meet and show. Give you a few extra days to get all those turned in. Now, what we're doing today is really an extension of what we did yesterday, talking about the use of these rational exponents and how we can manipulate them to simplify the expression into something a little bit simpler. Now, there's two ways we can talk about rational exponents, and these are kind of two of them here, a to the m over n. What we can do is we can take it and split it apart into a to the 1 over n to the mth power. Because powers of powers multiply, and we can actually split them apart. So we're just taking it, m over n, and rewriting it as a to the 1 over n to the mth, which is really just the nth root of a to the m, and then we can simplify that root down to something that's a little bit easier to work with. Now, if the exponent's negative, we can move it from the numerator to the denominator and do the exact same thing, except it's going to be in the bottom of the fraction instead of the top. Now, this will make a little more sense when we kind of look at it and work through it. And realistically, I was just rewriting down the steps that we already had. So all that was actually already on the paper. So you're good? Now, when we look at the first one here, 16 to the 3 halves, what we can do is we can rewrite this as 16 to the 1 half cubed. 16 to the 1 half cubed. Because we can break that rational exponent apart into two different parts. And what we can do now is we can rewrite the fractional exponent as a radical. The number in the numerator of our rational exponent is the number that goes inside with the 16. Since it's 1, we just have 16 to the first, which we don't actually have to write it because it's just going to be 16. The number on bottom is our index. So we can write an index of 2, but it's also understood if we don't write the 2 that it is a square root. So what we're trying to find now is the square root of 16, and then we're going to put that to the third. Well, what is the square root of 16? It would be 4, because we're trying to see what number times itself is, which is 4. And now the last thing we need to do is take 4 to the third power, multiplying it by itself 3 times, which is 64. Any questions on any of this here? Okay. Now let's look at the second one here. We have 32 to the negative 3/5. Now since the exponent's negative, the first thing we can do is take it from the numerator to the denominator. Because anytime we move a number from the numerator to the denominator, or the denominator to the numerator, from the bottom of the fraction to the top, or the top to the bottom, the exponent goes from positive to negative, or negative to positive. Since the exponent is negative, moving it to the denominator is going to make it positive. Now at this point here, we can break that fraction up so that we have 32 to the 1/5 to the third. Really what this is telling us is that we have the radical 32 is going to be inside to the first power because the number on top of the 1/5 is 1. And the root that we actually have is 5. So what we're wanting to find is the 5th root of 32. So we're wanting to see what number times itself 5 times gives us 32. And well, there's different ways we can do it, and one of them is a factor tree. So we can say 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. Well, that gives us 2 a total of 5 times, yes? So the 5th root of 32 is, well, 2. And since that did come out to a whole number, we could have taken the 5th root of 32 in the calculator and it would have told us that it's 2. Well, the last thing we need to do is simplify. We need to find out what 2 to the 3rd is. And 2 to the 3rd is 8. So the final answer is actually 1/8. And again, most of the ones that we did here, both of these here could have been done in the calculator and given us a nice answer. But the reason we're doing this is to get a familiarity with the properties of how these work, how we can simplify them, so that when we start working with some that don't simplify to a nice number, we know what we're doing. Any questions on any of these here? So we're going to look at these two here. 64 to the 4/3. So what's the first thing we can do for this one here? Well, you can rewrite this to the 1/3 to the 4th. Now, as we've seen already today, 1/3 is really the same as the cubed root. Yes? So we're really wanting to determine what number times itself 3 times is 64. Well, we can do the factor tree. What's our smallest prime number that goes into 64? Well, we can say 2, yes? It would be 2 and 32, which is 2 and 16, which is 2 and 8, which is 2 and 4, which is 2 and 2. So how many 2's do we get? 1, 2, 3, 4, 5, 6. So that's a little more 2's than we wanted, isn't it? Because we'd wanted a number to the 3rd, because that would have been a little bit nicer to work with, yes? I have to erase this because I'm going to run out of room. Now, 1/6 or 1/3 times 6 would be 6/3, yes? 1/3 times 6 is 6/3. But what is 6 divided by 3? 6 divided by 3 is 2, yes? 2 squared is what? 4, yes? Question. Now we just need to figure out what 4 to the 4th is. I believe it's 256. Any questions on this here? What is 4 cubed? Do y'all know what 4 cubed is? 4 squared is 16, yes? And if we do 16 times 4, you don't have to write this down, is 64. So really, instead of using 2 to the 6th, we could have used 4 to the 3rd. It would have worked the exact same because, well, we end up getting 4 to the 4th. Even though we went all the way down to 2, we still ended up getting back to 4 because it still works out the same. So I'll show you that here. Because if we just sing, bless you, that, well, this is 4 because the cubed root of 64 would just be 4, then we can just say 256. But using 2 works out just as well. It just has a few more steps to it. Any questions on this here? Let's look at the next one. 16 to the negative 5/4. Well, what can we do first in evaluating this? Well, the exponent's negative, so we need to make it positive by moving it down to the denominator. And then we can rewrite this as 16 to the 1/4 to the 5th. Now, 16 to the 1/4 is really telling us that we're trying to find the what? This here tells us we're wanting to find the 4th root of 16. We're wanting to find what number times itself 4 times is 16. What number would that be? If we look at a factor tree, 2 times 8 is 16. 8 is 2 times 4, and 4 is, which gives us a total of 4 2's. So the 4th root of 16 is 2. And lastly, we need to find 2 to the 5th. Well, what is 2 to the 4th? 16. So 2 to the 5th is just multiplying 16 by 2, which gives us and that's it. Any other questions on these here? All right. There's no questions on this here. The next set of 3 problems are some that I think that y'all like a little better. Evaluate expression using a calculator. So we look at the first one, 9 to the 1/5. We can use the calculator and say 9 to the 1 divided by 5. And it tells us it's 1.55. We just plug it in. All we have to do to evaluate it using a calculator is we just type it in. We could also have done 9 to the 1/5 using a fraction instead of the division, but it would still give us the same thing. And since it wants us to go to 2 decimal places, it'd be 1.55. And that there would be our answer. And we would expect the number to get smaller because our exponent is less than 1. We're trying to find what number times itself 1/5 of a time gives us 9. or what is 1/5 of 99? Or, yeah, no, sorry. If you have any missing assignments, get them done by Monday, and have a good weekend. So, actually, what we're finding here is what number times itself 5 times is 9. I don't know why I was saying 1/5. Yes, because this here is really saying that we're taking the 5th root of 9. So we're trying to find what number times itself 5 times gives us 9. So we expect it to be something small. 12. Now 3/8, since it's to the 3/8 power, we would expect the number to get smaller. And again, all we've got to do is plug this into the calculator. So we take 12 to the 3/8 and hit enter, and it tells us that it's 2.53917. But if we're going to 2 decimal places, it'd be 2.54. Yes. And the last one, again, we can plug it in exactly as we see it, parentheses, 4th root of 7, close parentheses to the 3rd. And if we type this in, four, 7. 4.30. We agree with 4.30? Since everybody is typing this in. Totally. Any questions on these here using approximates? Just typing them into the calculator. Now, okay. So 7 to the 1/4 would be? So 1.2 decimal places? 6.3. Now we can look at 10 to the 2/5. 2.51. And the last one. Now looking at the last one, realistically, or another way that we could have written this is, well, this would be 11 to the 1/3, yes? And if we multiply it by the 2, we get 11 to the 2/3. So if I wanted to, we could actually type it in that way there and say 11 to the 2 divided by 3. And I believe that's the exact same thing we got. So writing them in the different ways, one can be more helpful than the other, depending on which calculator you're using. Any questions on these here? Now, the last thing we're going to be doing today is solving these equations using the nth root. Solving an equation using nth roots. To solve an equation of u to the n equals d, we're going to use these where u is an algebraic expression to the nth root of each side. We've done this before. But what we called it was the square root method. Because we've done the square root method. And we use it. Huh? Oof, I don't know. But they're very on the nose. And a lot of mathematicians do that, and they say in science too, but they really say, or one of the professors that I had put it, you know, you've made it big in math and science when they stop capitalizing the first letter of your name in the theorem, because that theorem has become so commonplace that it's not a proper noun anymore. It's actually just a common noun because it's used so much. Because essentially, instead of saying Riemann sum with like an R, capital R, it's just lowercase r, because it's being used so much it's common. Now, to solve these here with a set of parentheses or the variable by itself, what we need to do is get the variable by itself first. Or you can go back later and hear your own name years down the road. All right. Okay. So to use the nth root method, we need to get the variable by itself. And we can use this since there's only one variable in the entire equation. So the first thing we can do is divide both sides by 4, which tells us x to the 5th is equal to 32. Now this is similar to the square root method that we did last semester with quadratics, because we had just x squared, 4x squared equals 128. And we would divide both sides by 4 and get to this here. Now, with the square root method, we would take the square root of both sides. But we can't take the square root of both sides here. We need the 5th root, because we have x to the 5th. When we were using the square root method, we didn't have x to the 5th, we had x squared, so we would take the square root. And really the reason we're doing this is because the 5th root is the same as putting this to the 1/5 power. And our powers of powers would multiply, telling us that we have x to the 5/5. Well, anything divided by itself is 1. And well, x to the 1st is just x. Now, we don't have to do that every single time. That's what we have been doing when we just say, okay, the 5th root of x to the 5th, these cancel, telling us that we just have x is equal to. Now we need to find the 5th root of 32, which is 2. And when we type it in the calculator, we could type it in as the 5th root of 32, or we can type it in as 32 to the 1/5, because those are the exact same thing. And a lot of times when I type these in the calculator or trying to find them, I'll use the fractional exponent over trying to get the radical, because it's a little bit easier and a little bit faster to type in. Now, one thing we do need to be careful with is looking at the root. Here the root is odd, and as we covered it towards the end of the lesson yesterday, if the root is odd and what's inside is negative, we would have one real root. If we can have no real roots, one real root, or 2. Whenever it's odd, we can have one real root, or one real root. So whenever the root, the number of the index is odd, we're only going to come up with one answer, no matter what's inside the radical. If it's even, if it's an even root, so 2, 4, 6, 8, and what's inside is negative, we have no real roots. The square root of 0 is 0. Because this here is saying what number, because we're trying to find the number multiplied by itself, whatever the root is, to get to that number. So here we're trying to find what number times itself is 0. Well, 0. And no matter how many times we multiply 0 by itself, it's still 0. And if the number inside the even root is positive, we're going to have 2 real roots. No comment. Luckily, they could have been harder.
I would have failed, but difficult, but like still passing.
Let's look at this one here next. Now this one here is a little bit different because we don't just have a term, an x by itself. We have a set of parentheses to a power. Now, if there had been another variable outside of the parentheses, we couldn't use this method. But since the only variable in this equation is inside of our parentheses, we can use the nth root method. Now, the first main thing we would need to do is to get the parentheses by themselves, but luckily for us, they already are. So what we can do, guys, is we can take the fourth root of both sides. Because when we take the fourth root of both sides, the fourth root and the exponent of 4 will simplify out, leaving us with x minus 3 is equal to the fourth root of 21. Now, since we are taking an even root this time, and what's inside the radical is positive, it can be positive or negative. We have 2 roots. So we have the plus or minus that we have to include. Any questions on this so far? Is the variable by itself? Well, no, we've got the minus 3, yes? So to get it by itself, we need 2. Add 3 to both sides, telling us x is equal to 3 plus or minus fourth root of 21. Now this is as far as we can take it because it's not asking us to approximate this answer or round this answer to the nearest tenth or the nearest hundredth. It's just wanting this exact answer. So we can leave it in radical form because the fourth root of 21 is not a whole number. It has an ugly decimal to it. Because our fourths, 2 to the fourth is 16. 3 to the fourth is 81. So really no number between 16 and 81 has a nice fourth root. So 21 is not going to have a nice number. So we can leave it as this here. And that's all we have to do for this. Any questions on this here? Okay. We'll look at one more of each and then we're actually done for today. Now looking at this problem here, 5x to the third equals 320. What is the first thing we can do to solve this equation? We can divide both sides by 5. 5x cubed divided by 5 will leave us with x to the third is equal to 320 divided by 5 is 64. And lastly, we need to cubed root both sides. And if we take the cubed root of x to the third, we get x. And the cubed root of 64 is, so we get that x is equal to 4. And that's it. Now, and again, because the root is odd, we took a cubed root, we only have one solution, or one real root. And we're only finding real roots for these here. Any questions on these here? We ready for the last one? Okay. I want to skip a few and go to this one here. Because I want to look at one even root that actually does work out nicely. So, looking at this here, we do have a set of parentheses and they're already by themselves. So what we can do is take the fourth root of both sides, because the fourth root and the exponent will actually simplify out, leaving us with x plus 5 is equal to 2. Now again, we're taking an even root, so we need the plus or minus. Anytime we take an even root, we have to add the plus or minus for these here. Now, is the variable by itself? Well, no. So we need to subtract 5 from both sides, which will tell us that x is equal to negative 5 plus or minus 2. Now, this one here is a little bit different because we don't have a radical anymore in our answer, unlike the other one that we had that was even. And looking at this here, can we calculate negative 5 plus 2 and get a number? Yeah. Because we can take negative 5 plus 2. And negative 5 plus 2 is negative 3. And we can also take negative 5 minus 2, which is negative 7. If we're able to calculate them and actually combine those terms, we need to do it. And that's why I wanted to do this one here. So this one here, we don't leave in this negative 5 plus or minus 2 because we can actually add and subtract those two numbers. So we need to do it. Now with the previous one, the fourth root of 21, since that gave us an ugly decimal and it wasn't asking for us to approximate, we could leave it in that form. Here, we can combine them and get whole number answers. So we want to do that. Any other questions on this here? And that's it. And that's all we're doing for today.